Hello everyone, this is Professor He. Nice to see you again. The topic of this task is about the general relations for specific heats. Recall that the specific heats of an ideal gas depend on temperature only. For a general pure substance, however, the specific heats depend on specific volume or pressure as well as the temperature. At low temperatures, gases behave as ideal gases, and their specific heats essentially depend on temperature only. These specific heats are called zero pressure or ideal gas specific heats, and they are relatively easier to determine. It is desirable to have some general relations that enable us to calculate the specific heats at higher pressures from a knowledge of CV0 or CP0 and the PVT behavior of the substance. Such relations are obtained by applying the test of exactness on the first and the second DS equations, that is, applying the test of exactness on the first and the second DS equations, the derivatives for the specific heats are yielded. The deviation of Cp from Cp0 with increasing pressure, for example, is determined by integrating the latter equation from zero pressure to any pressure along an isothermal path. Another desirable general relation involving specific heats is one that relates the two specific heats, Cp and Cv. The advantage of such a relation is obvious. We will need to determine only one specific heat, usually Cp, and calculate the other one using that relation and the PVT data of the substance. By equating the two ds relations and solving for dt, the exact differential of t with natural variables of v and p is equating the coefficient of either dv or dp of the preceding two equations gives the desired result of the difference of the specific heats. An alternative form of this relation is obtained by using the cyclic relation. From the cyclic relation, we have the change in pressure that occurs when temperature changes while volume remains constant. Then the difference of the specific heats is. This relation can be expressed in terms of two other thermodynamic properties called the volume expansivity and the isothermal compressibility, and we obtain a third general relation for Cp minus Cv. This is called the Mayer relation in honor of the German physician and physicist J.R. Mayer. For an ideal gas, try to show this relation. We can draw several conclusions from the Mayer relation. The first one is the isothermal compressibility is a positive quantity for all substances in all phases. The volume expansivity could be negative for some substances, but its square is always positive or zero. The temperature T in this relation is thermodynamic temperature, which is also positive. Therefore, we conclude that the constant pressure, specific heat, is always greater than or equal to the constant volume, specific heat. The second one is the difference between Cv and Cp approaches zero, and the absolute temperature approaches zero as well. And the third one is the two specific heats are identical for truly incompressible substances since constant specific volume. The difference between the two specific heats is very small and is usually disregarded for substances that are nearly incompressible, such as liquids and solids. Okay, that's all for this task. Thank you very much, and see you next time.